Manned missions to space are expensive. Going beyond Earth orbit, even more so. For instance, the total estimated cost of the Apollo program to send the first humans on the moon costed around $25 billion. That is equivalent to $175 billion today, making it one of the most expensive government initiatives in American history. Today it costs around $20,000 to put a kilogram of payload in Earth orbit. Engineers at NASA are developing technologies for 21st century that will not only dramatically increase the safety and reliability, but will also reduce the cost of space transportation. Under the Artemis program, NASA want to explore more of the moon than ever before. To reduce the cost of the new moon missions, we need to exploit resources which already exist on the lunar surface. Take water, for example. As water is a dense and heavy substance, it takes a lot of energy to propel it into space, resulting to an enormous cost. However, there may be water ice present on the moon's surface near the lunar poles, that when excavated could be melted, purified, and used for rocket fuel. So, if there is water ice on the moon, how do we find it? According to Barbara Cohen, chief investigator at NASA's Goddard Space Flight Center, while there is a very good indication of ice inside the darkest and coldest craters on the moon, our previous measurements were rather ambiguous. Scientifically, that's fine, but if we're planning on sending astronauts there to dig up the ice and drink it, we have to be sure it exists. Enter the Lunar Flashlight of NASA, also known as CubeSat. The tiny satellite, weighing only 14 kilograms, aims to detect surface ice, which according to previous studies occurs naturally at the bottom of craters on the moon. This is the first mission to look for water ice using lasers. It will also be the first planetary spacecraft to use a green propellant, which is a new form of fuel, safer than the commonly used hydrazine propellant. Over the course of 2 months, Lunar Flashlight will swoop low over the moon's south pole and use its near-infrared lasers to shine light into the shaded polar regions, while the on-board spectrometer measures surface reflection and composition. In addition, it seeks to fill a critical gap in our understanding of how much water ice these regions possess. These dark craters are thought to be cold traps that accumulate molecules of different ices, including water ice. The molecules may have come from comet and asteroid materials impacting the lunar surface, as well as from solar wind interactions with the lunar soil. With the Artemis program, humanity's return to the moon will begin with robotic missions in 2021, humans in 2024, with the goal to establish sustainable lunar exploration by the end of the decade. Then, NASA will use what we learn on and around the moon to take the next giant leap, sending astronauts to Mars. Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.